Welcome. Today onwards we will see root locus problems. That is, equation is given to you and we have to find out or we have to draw the root locus of that characteristic equation. Now the first problem, draw the approximate root locus diagram for a closed loop system whose transfer function is given by GSHS is equal to K divided by S into bracket S plus 5 into S plus 10. Comment on stability. Now solution. Here given transfer function is GSHS is equal to K divided by S into bracket S plus 5 into S plus 10. Therefore, step 1, calculation of number of poles and number of zeros and number of branches. Now here in the denominator there are three values of S, that is S plus 5 and S plus 10. Therefore equating it to 0 we get number of poles as S is equal to 0, S is equal to minus 5 and S is equal to minus 10. Therefore number of poles P is equal to 3, which are 0, minus 5, minus 10. Now the numerator is having only K term with no S terms. Therefore number of zeros Z is equal to 0. Now to calculate number of branches, that is N is equal to P minus Z, which is equal to 3 minus 0, which is equal to 3 branches. Therefore all are starting from 0, minus 5, minus 10 and ending at infinity, as there are no zeros. Now step 2, we have to determine root locus region and no root locus region. Now first of all draw x-axis, it is known as real axis. Then draw y-axis, it is known as imaginary axis. Now locate number of poles and zeros. Therefore number of poles are 3 only. Therefore 0, minus 5, minus 10. Therefore locate first pole at 0. Poles are represented by cross. Zeros are represented by circle. Therefore 0, minus 5, minus 10. Now from this graph we have to find out root locus region and no root locus region. Now consider first pole, that is 0. Now towards right side of 0, how many poles and zeros are there? 0. Therefore towards right side of 0, no root locus region is there. Now consider next pole, that is minus 5. Now towards right side of minus 5, how many poles and zeros are there? Only one pole and 0 number of zeros. Therefore addition of P plus Z is equal to 1. It is having odd number. Therefore you can say that between minus 5 and 0 root locus region exists. Now consider minus 10. Towards right side of minus 10, how many poles and zeros are there? That is addition of P plus Z is equal to 2. That is only 2 poles are there and 0 number of zeros, that is 2 plus 0 is equal to 2. Therefore it is even number. That's why we can say that between minus 10 and minus 5 there is no root locus region, and towards left of minus 10 there exists root locus region up to minus infinity. Therefore this is the procedure to determine root locus region and no root locus region. Step 2. Now step 3, angle of asymptotes. Angle of asymptotes is equal to number of branches. Always remember, since number of branches n is equal to 3, therefore angle of asymptotes is equal to 3. Now angle of asymptote is calculated by using equation theta is equal to 2q plus 1 into 180 degree divided by p minus z. Now n is equal to 3, therefore we have to substitute 3 values of q, that is q is equal to 0, q is equal to 1 and q is equal to 2. Therefore by substituting that 3 values, first of all we are getting theta 1 is equal to 2 into 0 plus 1 into 180 degree divided by 3 minus 0. Therefore by doing calculation, theta 1 is equal to 60 degree. Similarly, theta 2 is equal to 2 into 1 plus 1 into 180 degree divided by 3 minus 0, which is equal to 180 degree. And theta 3 is equal to 2 into 2 plus 1 into 180 degree divided by 3 minus 0 is equal to 300 degree. Therefore, these three angle of asymptotes are there, 60 degree, 180 degree and 300 degree. We have to plot this angle of asymptotes through the centroid. Therefore, next step is to calculate centroid sigma. Now, step 4, calculation of centroid. Centroid sigma is given by summation of real parts of poles minus summation of real parts of zeros divided by p minus z. Therefore, sigma is equal to, now all poles are real poles and no zeros are there. Therefore, 0 minus 5 minus 10 minus 0 divided by 3 minus 0, which is equal to minus 5. Therefore, sigma is equal to minus 5. Therefore, locate sigma is equal to minus 5 on the graph and draw the angles, that is 60 degree, theta 1 is equal to 60 degree, theta 2 is equal to 180 degree and theta 3 is equal to 300 degree. We have to draw these angles through the centroid. Now next, breakaway point. Always remember, breakaway point exists in the root locus region only. Breakaway point is the point at which root locus leaves or enters the real axis, that is x-axis. The characteristic equation is 1 plus GSHS is equal to 0. Therefore, 1 plus k divided by s into bracket s plus 5 into s plus 10 is equal to 0. Therefore, s cube plus 15s square plus 50s plus k is equal to 0. Therefore, k is equal to minus s cube minus 15s square minus 50s. Equation 1. Therefore, differentiate this equation 1 with respect to s and equate it to 0. Therefore, dk by ds is equal to minus 3s square minus 30s minus 50 is equal to 0. Therefore, minus 3s square minus 30s minus 50 is equal to 0, or s square plus 10s plus 16.67 is equal to 0. Now, this is the quadratic equation. We have to solve this quadratic equation and we will get two values of s. One value will be valid value, one value will be invalid. Therefore, this is the formula to find out the roots of the quadratic equation. S is equal to minus b plus minus square root of b square minus 4ac divided by 2a. Therefore, substituting the values, s is equal to minus 10 plus minus square root of 10 square minus 4 into 16.67 divided by 2. Therefore, we are getting two values of s, that is minus 2.113 and minus 7.88. Now, we have to check which value of these out of these two lies in root locus region. Therefore, that value is considered as valid value and other value is considered as invalid value. Therefore, we have seen that there exists root locus region between, again we will go back, this 0 and minus 5. Root locus region is there between 0 and minus 5 and minus 10 to the minus infinity. Therefore, the value which lies between 0 and minus 5, which that means minus 2.113. Therefore, this is nothing but valid breakaway point. The value which lies in no root locus region, that is minus 7.88, which lies between minus 5 and minus 10. Therefore, you can say that this is not a valid breakaway point, that is minus 7.88. Therefore, only one breakaway point is there, that is minus 2.113. Now, step 4, intersection with step 6, intersection with imaginary axis. Now, we have our characteristic equation as s cube plus 15s square plus 50s plus k is equal to 0. Now, by using Routh's array, we have to find out value of k. Now, first of all, you have to write s cube, s square, s raised to 1, s raised to 0. Now, s cube coefficient is 1. We have to switch over like this. Then we have to go to s 1, 50, then 15, S square coefficient is 15, 15 S square, and this K we have to write. Now how to obtain value of S raised to 1? We have to multiply 15 into 50 minus K into 1 divided by 15. And again here value 0 will be there because here zeros are there. And similarly S raised to 0, we have to multiply 15 into 50 minus K divided by 15 into K minus 15 into 0 divided by this value. Therefore we are getting in front of S raised to 0 K. Now from row of S raised to 1 we have 750 minus K divided by 15 is equal to 0, or 750 minus K is equal to 0. Therefore K is equal to 750. As K is positive, it must intersect with imaginary axis. Again the auxiliary equation is AS is equal to, from the Trout survey we have taken this equation, AS is equal to 15S square plus K is equal to 0. Therefore substitute value of K, 15S square plus 750 is equal to 0. Therefore S square is equal to minus 750 divided by 15 is equal to minus 50. Therefore S is equal to plus minus J into square root of 50. Therefore S is equal to plus minus 7.071 J. Therefore this is nothing but this point plus minus 7.071 J is nothing but intersection with imaginary axis. Now step 7, angle of departure. Since no complex poles, hence calculation of angle of departure is not required. Root locus breaks at plus minus 90 degree at breakaway point. Now step 8, stability of system. For the range 0 less than 750 less than K, system is stable as entire root locus lies in the left half of S plane. At K is equal to 750, the system is marginally stable. For 750 less than K less than infinity, system is unstable as root locus now move in right side of S plane. Now these are the different steps. Now we will see how to plot the root locus. Therefore step 1, at first problem only I will tell these different steps. Afterwards directly we are going to draw the root locus. Consider x-axis as real axis. Therefore mark the points. Draw this on the graph. 0, minus 1, minus 2, up to minus 10, minus infinity. Then 0, 1, 2, 3, 4, 5, up to plus infinity. Then on imaginary axis 0, 1, 2, 3, 4. On imaginary axis on downward side 0, minus 1, minus 2, minus 3. Now step 2 is nothing but we have to determine root locus region, no root locus region. Therefore we have located poles at 0, 5, minus 5 and minus 10. Therefore earlier we have seen between 0 and minus 5 root locus region exists. Between minus 5 and minus 10 no root locus region is there. And to the left side of minus 10 root locus region exists. Therefore indicate root locus region, no root locus region, and root locus region again on the graph. Now locate the centroid. Step 3, locate the centroid. What is the value of centroid? Minus 5. Therefore locate that point minus 5. Now step 4, draw the angle of asymptotes through the centroid. Now this through the point minus 5, draw the three angles. Theta 1 is equal to 60 degree, theta 2 is equal to 180 degree, and theta 3 is equal to 300 degree. Therefore draw these three angles through the sigma is equal to minus 5. Now location of breakaway point. Always remember breakaway point exists in the root locus region only. Therefore we have only one point, that is minus 2.11. Therefore locate that point between 0 and minus 5. Breakaway point, indicate it as breakaway point. Now step 6, we have calculated 2 points, plus 7.07 J and minus 0.07 J. That is nothing but these points are intersection with imaginary axis. Therefore locate that 2 points. Intersection of imaginary axis means what? Root locus is intersecting imaginary axis at some points. Therefore that points we have calculated as plus minus 7.07 J. Now we have to plot the root locus. Now always remember root locus starts from open loop poles. root locus starts from open loop poles. Therefore, this root locus will start from -5. Again, it will start from -0. Like this, it will go. Now, this is the breakaway point. Breakaway point means what? It will leave the real axis. Therefore, one branch will move like this, parallel to theta 1 is equal to 60 degree, and it will intersect at 7.07j, and it will go to infinity. Another branch, this is the first branch. Another branch will come downward side. It will intersect the imaginary axis at -7.07j. It will go to infinity. And third branch will be there. It will start from -10, and it will go to -infinity. Therefore, these are three branches of root locus. Therefore, this is your root locus graph. Now, on graph paper also we have plotted. Therefore, this is the graph. X-axis real axis, y-axis imaginary axis. Locate the points. Take proper scale. 0, -1, -2, -3. Root locus region, no root locus region, root locus region. See that sigma is equal to -5. This is the breakaway point, -2.11. These are the intersection with imaginary axis, plus 7.07j, -0.07j. Therefore, root locus starts from -5. This, and it will start from 0 also, because root locus starts from poles only. Therefore, first it will start from -5. It will go to here. Again, it will leave the real axis, and it will intersect with imaginary axis at plus 7.07j. This is first branch. Now, second branch will start from 0. It will go to -2. Again, it will leave to the real axis, and it will intersect -7.07j. This is the second branch. And third branch is, it will start from -10, and it will go to the infinity, -infinity. Therefore, this is the first problem. Draw this problem on the graph, then and there you will understand. Thank you very much.